In this video, we will look at some of the problems of the geometric distribution. So the first problem we have is that an unfair coin is tossed until a head appears. Now, what is the probability that the coin will be tossed 10 times if the probability of having a head is zero point 0.2? So this is not a fair coin, this is an unfair coin. And what is exactly this question is asking is that what is the probability that the head will appear in the 10th toss? All right. So the probability is simply given as uh, in the first toss, in the first 9 toss, what we want is tail to be appear. All right. And what is the probability of having a tail is 0.8. All right. And how many times do we want? We want it to be 9 times, and at the 10th time we want head to be appear. What is the probability of having a head? It is 0.2. All right. So this is our probability, and this gives the formula for our uh, geometric distribution. So how do we define a geometric distribution? So suppose the probability of happening an event, let's say we have any event A, then the probability of happening an event is let's say K, uh, let's say P, the probability is P, the probability is P, small p, alright. Now, in what is the probability? So, we do the experiment, we do the trials, alright. So, what is the probability that this event will occur at let's say kth time, in the kth time, alright. So, in the k, uh, in the first k minus 1 experiments, we do not want this event to happen, all right. And what is the probability that this event does not happen is 1 minus p, and we want it to happen k minus 1 times, all right. And at the kth trial, we want this experiment to happen, and what is this probability? P, all right. So this is the geometric distribution, all right, that an event occurs at the kth trial, all right, and p is the probability of happening of that event. In Ludo, a player needs to repeatedly throw a die till she gets one. So let A be the event that she gets one, and the probability of A is 1 by 6. What is the probability that she needs less than 6 throws? All right. So first we find lesser than 6 throws. Okay. Now probability x is less than or equal to 5. Right? And this is given by the formula 1 minus p k. All right. Now the prob it is important to note that what is the probability that she will need more than 5 throws. Okay, more than 5 throws. This is given by 1 minus p k. Alright, so this is an important identity that you need to keep in mind. Alright, and equal to or less than 5 will be this. Okay, and let's say the second question, it is she needs lesser than 11 throws. Okay, so again simple, lesser than 11 throws, which is equal to less than or equal to 10, and it is given by uh, 1 minus p 10. All right, and here, yes, and the second question is, let's say if we were asked greater than 10, it would be 1 minus p to 10. All right, and similarly she needs lesser than 21 throws, then x 21 it will be 1 minus, well, actually lesser than, if she needs lesser than 21 throws, then she needs less than or equal to 20 throws and P 20. So this is the formula for geometric distribution. So let's look at this question. This is an interesting question. Player 1 is a 40% free throw shooter, while player 2 is a 70% shooter. Each throw is independent of all previous throws. The two players alternate shooting, with player 1 starting till the first basket is scored. So what is the probability that player 1 before the player 1 wins before the third round? Alright, so let's look at the first part. So if player 1 has to win before the third round, is that player 1 wins in the first round, or player 1 wins in the second round? Alright, so because because player 1 is starting, so if he wins the first round, he he wins in his own turn. Alright, so probability zero point 0.4. Alright, that he shoots or throw the basket in the first turn, plus. Second is that in the first round, both the player misses, which is zero point 0.6 into zero point 0.3. Alright. And in the first turn of the second round, player 1 wins. Alright. So, and that will be the probability of 4. So this will be our answer. Now let's look at the second part. So what is the probability that player 1 wins? So what are our favorable outcomes? So the first favorable outcome is that player one wins. Let that the win of the player one denoted by S1 and its failure denoted by F1, and the win of the player two is denoted by S2, and the failure of the player two is denoted by F2. So the favorable outcome is that FS1, or we want F1 and then F2 and then S1, or, and this comes out to be, let's say, zero point 0.4, and this come out to be uh, both failed, so 0.18 into zero point 0.4. Then F1, F2 that both failed in the first two rounds, and then S1 wins, so 0.18 into to the power 2 into zero point 0.4, and this keeps going on and on. 0.4 into zero point 0.4. All right, and now we have to find the sum of all this. That is zero point 0.4 plus into zero point 0.4, and so on to infinity. And this is the sum is given by A1 minus R. Alright. Here our A is the first is given zero point 0.4, and R is given as 0.18, so 1 minus 0.18. So this is the solution that we have. Alright. Remember this geometric progression, that A plus AR plus AR1 and so on to infinity is given by A on 1 minus R if R is less than 1. Alright. So this was a very good question. So let's look at this question. A football match between Argentina and Portugal is going on. Until the last minute, none of the teams has scored a single goal, so the match referee decided to go for penalty shoot. From Argentina, Messi will go for penalty all the time, and from Portugal, Ronaldo will go for the penalty each time. There's a 40% chance that Messi can convert that penalty into goals. So P into M is equal to zero point 0.4, whereas 70% chance that Ronaldo can convert penalty into goals. So P into Ronaldo is zero point 0.7. Each penalty shoot is totally independent of the previous one. The two players will go for penalty shoot alternatively, and Ronaldo will start the penalty. So that is important. If Ronaldo hits the penalty first, then Portugal will win, and Messi will not be allowed to do the penalty, assuming no boundation on number of penalty. All right. So what is the probability that Messi wins before third round of penalty? So what are our favorable outcomes? So Messi has to win. So first of all, that so Ronaldo is starting. Ronaldo fails. All right, Ronaldo fails, and Messi wins. So this is one plus both of them fails in the first round, and then in the second round, Ronaldo fails, but Messi wins. So these are the two we have. So the probability that Ronaldo fails is zero point 0.3 and Messi wins is zero point 0.4 plus again Ronaldo failed 0.3, then Messi also failed 0.6, then Ronaldo again failed, and then Messi won in the second round, and his probability of winning is zero point 0.4. So this is the answer. All right. Now let's look at the second question, second part of the question. So what is the probability that uh, Ronaldo will win? So what are the again favorable? Just a second. Favorable circumstances. So Ronaldo wins, okay, and the probability is 0.7. All right. Then so both of them fails, and then Ronaldo wins. So both of them failed in the first round, and this is to be 0.3, which is the probability of Ronaldo fails, and then zero point 0.6 of Ronaldo failing, and then Ronaldo wins. And then the same that both of them fails in the first two rounds, and the Ronaldo wins in the basically third round. And this is again all right. And this keeps going and going. So this results in our geometric progression, which is zero point 0.7 plus 0.18 into 7 into zero point 0.7 and so on to infinity. And this is given by a upon 1 minus r. A is here zero point 0.7 and 1 minus 0.18. So this is the probability that Ronaldo wins.